welcome to a new video. So before we begin, there are certain stuff that's in the board, but no need to get confused. We will go through everything one by one as usual. Now, before we start, there are certain things that I need to tell you guys. So memory, what is memory? So memory for here, we name it as RAM and ROM. So RAM stands for random access memory and ROM stands for read-only memory. So that's all for now. Now, the second stuff that you need to remember is for 8085, it is capable to allocate 64 kilobyte of memory. 64 kilobyte of memory stands for RAM plus ROM. Okay, so 64 kilobyte of memory is equivalent to 2 power of 15. Alright, and it is also equivalent to 0000 till FFFF. Okay, so the address. So every RAM and ROM is something that needs to be pointed to a specific address. So this microprocessor is capable of giving 64 kilobyte of address line, which stands for 0000 till FFFF, which we denote by 2 power of 15. So the block, if you remember from the previous lecture, we have 0000 till FFFF. Okay, so we can divide it, we can partition it for the memory and ROM. Now, the design is actually based on the engineer and the student. If they are capable to understand the AND gate or gate digital circuit logic, they could easily bypass this design. If they have any problem with it, then it could be quite a problem. So now we are given appendix with this and tri-state logic. Tri-state logic is nothing to be worried about, and we are also given by a decoder decoding table, which is good. Now, is this image quite daunting or haunting? So we remove this image. Now we are given the same set of image in a block diagram or architecture diagram. So just now we know that the D latch had many pins and it was confusing. Actually, the D latch is simpler in this term. Now, the stuff that you guys need to be familiar with is, for example, if we see here, it's a 2732 it's actually EEPROM, the EPE ROM, so it should be EEPROM. Okay, it's not EPE ROM. Never mind. So it's 2732. From this diagram, what we could get as, we have A0, it should be A11, A0 to A11. So we have 12 address inputs. Then it has 0 to O0 to 07. We have 8 output. OE means output enable and CS means chip select. So these two are same. Then we are given a 8K RAM. So for this 8K RAM, we know that we have A0 till A12, it's not 13. So 13 address input. So usually it's 11, but because we need to take the 0, so it will become 12. So 12 plus 1 becomes 13 again, not be confused. IO 0 till 7, which means 8 data, because 7 plus 0, which means 0 0 0 is also considered. Okay, I will show it sooner, don't not be worried. So WR is write enable, OE means output enable, and CS means chip select. Okay, these are stuff that we could analyze from the chips block diagram. Now, the diagram is noted as such. This diagram is here, we just tilted it horizontally. Now, for 8085, we have AD, means that this is a data. It could work as address and it would also work as input output. Okay, so this is strictly for address plus IO. This is only for address. This is enable latch, it's a long term, but we will name it as enable latch. This is for read, this is for write. And this is the decoder. We have 3 input and we have 8 output, which is 3 to 8 decoder. Here the G1 will always be positive, G2 and G2B will be negative, ground. Okay, so these are the basics, and these are the diagram that you can draw by your own to practice. Now let us do some mathematical practice, because we need to know mathematics for this. Now I said the address pin is 2 power of 10, which is equivalent to 1024. If you press your calculator, you'll know. And 2 power of 10, 10 is equivalent to kilo, so it's 1 kilo. And in hexa we call it 400, but for now hexa we could remove, or we want it, maybe we need it. Okay, maybe we need this guy, because this guy will help you guys out. Now range. So if 400, you guys maybe can ask, why not 000 till 400? Now 000 is taken account. It's not 0, it's actually a address location which is equivalent to 1. Okay, and what is 3FFF? I assume you guys are familiar with hex code conversion. Okay, now for example, if we take this one, address line 12 is equivalent to 210 plus 22, which is equivalent to 210 times by 4, which is equivalent to, this is kilobyte, this is 4, which will be 4 kilobyte, 4 kilo, 60 kb, so kilobyte. Okay, so in hexa we call it as 1000. Why? Later will be explained. But in range we call it 0FFF. How possible? How could? Now hex code is divided into 16 power of 0, 16 power of 1, 16 power of 2. Okay, now for 4096, okay, 4096 we call it as, did I do 4096? Yeah, I do 4096. So we said that it is 000 till FFF. Now FFF, how good? Okay, FFF means 15 times by 16 power of 2, 15 times by 16 power of 1, 15 times by 16 power of 0. I assume guys you know F is equivalent to 15. Okay, so it means that A is equivalent to 10, B is 11, and so on. Now this will result in this. If you plus it, you will get 4095. You may ask, it's just 4095, why 4096? We need to add 000 as well, which is equivalent to 1, so it will become 4096. Why 1000? As said, 4095 results in FFFF. So in order to add, you need to have another thing, 0000 as well. So it will result in 4096, which means so you will get as such in hexa. Okay, I hope now you guys know what's happening here. Why 400 but 3FF, why 800 but 7FFF, why 1000 but only FFF, because you need to add the base as well, which will be resulting in +1. Okay, this basic mathematics will help you sooner. So if you skip this, then congrats. Now as said, 8085 has 64 kilobyte addresses. Okay, now yeah, before we continue, it is equivalent to 215. We will separate it in nibble. So now as said, a 1 bit is set as 1 bit, a 4 bit is set as nibble, a 8 bit is set as a byte, and 16 bit is called as 2 byte. Okay, so now nibble means we will separate it from 20 to 23, 24 till 27, 28 till 211, 212 till 215, which should result in 0000, 0000, 0000, 0000. This would help in a while, so be prepared. Now for the decoding table, we only need to see the G1, because as said we only be using G1. And then for ABC, it as such. So if A, everything is 0, Y0 will be on, If A is 1, Y1 will be on. If B is 1, Y2 will be on. If both is on, Y3 will be on. How? Imagine this is 2 power of 0, 2 power of 1, 2 power of 2. Now, if 2 power of 0 times by 1 is equivalent to 1. 2 power of 1 times by 1 is equivalent to 2. And if this is equivalent to 3. So, here binary, you convert binary to decimal, you will get the answer, how to decode it. Okay, now let us see a question, but before that I want you guys to remember this. So this is from the 8085 and this is for the chip. Now from the 8085 RD, if you notice here, need to go to the output enable. So the read should always go to the output enable. So output enable, output enable, output enable need to connect with this RD. Now write should be equivalent to write enable. So write enable is only for the memory, need to be connected here. Then ALE is for enable. So latch enable will always go to the enable here. Okay. Then AD to AO, the address data need to be go on to the latch. Why? AD goes here but come out as A. What happen is AD027 which goes here will come out as A027 merging with A8 to 15. So you'll get AO till A15 which will result in this expansion and also this conversion. Now let us see a question. Okay. Now this question says that design the memory system by drawing a memory map and address decoding table. So we merge it as one. Use 2 units of 4K ROM and 1 unit of 8K RAM. Okay, so it says that 4K ROM, 8K RAM, and this one is nothing to be bothered about now because this appendix is here. So we are gonna use this exact image and a diagram, so no need to be confused by the wording and so on. Just refer to that table and then okay, so they are asking us to build a memory map. Before we begin, we need to know that 4K ROM is equivalent to 4096, which is equivalent to 2 power of 12. 8K RAM is equivalent to 8096 and 2 power of 13. Okay, so I said that 2 power of 16 is divided into such, we name it as 2 power of 15, apologize, 2 power of 15 actually. So we have if we make it as such, we have the A15, 14, 13, 12 in the high enable. Now let us do a quick math because we need to be using this table to draw this schematic. Okay, so this schematic involves 8-bit latch, which is easy. The decoding circuit. Okay, so we need to be careful. Now, as I said here, okay, we need to refer this. So if we refer this E11, so let me just make it 100 where 1111 and we will be using Y4. Yeah, so we have 3 stuff here. Okay, we have 3 stuff here. We need to be using 2 4K ROM and also 1 8K RAM. Okay, so 2 4K and 1 8K. So we name it as 2 4K, 1 8K. So we have total 3 chips to be using. Now, if normally we want to take Y0, Y1, Y2, we need to know that we need to have A as 0, A as 1 and B as 1. Okay, but there is a mathematical constraint here. Now I said that, okay, just imagine A11 till A0. Okay, because the highest that we could get is 2 power of 12, which means that for the first 4K RAM, we just put 4K 0 lah, the upper nibble will be 0 and here will be 0 0 0. Okay, which this will result in 0 2. Now it will be having till F F F F, am I right, for the 4K1. Now for the 4K2 we will be having 0 0 0 1, so 0 0 0 till F F F F, which means that we will be having till 1. Now for the 8K, now we will be having 0 0 0 till F2, but we started from 1000, but we will be ending till 3000. Okay, we will be ending till 3000. Why? Because as I said, 4K is equivalent to 0 0 0 till FFFF, but 8K means 0 0 0 till 1FFF, meaning that it's 2000, need to be twice. So if you are using, okay, in simple term, we will be using 0 0 0 0 till 0FFF, then 0 0, sorry, then 1000 till 1000FFF, which would result in 2000, and you need to use until 3000FFF, because 2000 till 2FFF, then you need to 3000 till 3FFF, which is 4K, which results in 8K. Now what's going to happen is, if you are taking A14 till A12, this is equivalent to Y0. Okay, this is equivalent to Y1, but this here is equivalent to Y2 and Y3. So when you are doing the decoding table, this one will go to 4K1, this one will go to 4K2. This both need to go into an OR gate to 8K, because the decoding table says as such. Now, did the appendix give you a OR gate? No. So you need to be clever here. We aren't gonna take A14, A13, A12 as our ABC. Alright. Now what we're gonna do is, we're gonna do some maths here. So if we do some maths, what we are gonna get is, somehow, please bear with me. Delete. Oh my god, never mind, we know the question, so no need to bother about it. Okay, so we have, okay, just remember, but I assume you guys draw the table correctly. So the correct table, okay, I might have place, so I'll write the correct one for you guys. Memory, then decoder, so we take A15, A14, A13, okay, then we have A12, then we have A11 till A8, A7 till A4, and A3 till A0. Then we have our hex. Okay, so decoder, and this one is input to memory address. Okay, why I separate decoder and input to memory address? Just as I said, 4K is equivalent to 2 power of 11, 8K is equivalent to 2 power of 12. So 2 power of 12, we need 12 address line to be fed to input memory. Actually input memory address divided here lah, A11. Okay, 2 power of 12 means A0 till A11 needs to go to the chips, because the higher range of 8K is equivalent to 2 power of 12. Okay, now the fuck, okay, sorry. Now we have this. Now the first thing we're gonna do is 4K ROM 1. Okay, 4K ROM 1, we know that the hex is going to be, if we start from 0, it's going to be 0FFF. Now the clever way that we're going to do is, we are going to make this CBA for decoder, right? So we don't care about this. So now we need A as 0, then it's going to be 0 0 till 0 lah. Okay, the dot means that it's 0 0 0 till 0 0 0. It doesn't mean that we stop. Okay, so we are not going to do the lengthy table and finish quite some paper here. We're going to just write as such, or you could do an arrow to make it simple, depends on the user. Okay, now we have done it. Now the next thing, we know that we're going to make A as 1. Okay, we're going to make A as 1 for the 4K ROM 2. Now we know that it's gonna make 000 till FFF2, but now the hex is gonna be 2000 till 2FFF. Why? Remember I said this is 0, this is 0, this is 0. If the 0, it means that the address is 0. Now here it means that we are doing 0010, which is equivalent to 2. Okay, this is equivalent to 2. So remember I asked you guys to make this as nibble. So what actually nibble means that we make every single 4 digit. If we convert this into hexadecimal, we get this as F, this as F, this as F, and this is either 0 or 1 or 2. Okay, that is why I ask you guys to make it as nibble, because this is 2 power of 8, 2 power of 4, 2 power of 2, 2 power of 1. The sum is equivalent to 16, which is F in hexadecimal. Okay, beware of that. Now here we know that it's gonna be 000 000 000 till F F F F and F F F F, also F F F F. Now okay, now we know that if A is 0, okay, we give it to Y0. If A is 1, we give it to Y1. Now we're gonna give it to Y2, means we need our B to be on. Okay, so this is going to be 8K RAM. Now if we get our B to be on, alright, actually I think I made a mistake here. Let me see what I did. Okay, no, I didn't do a mistake. Now this is VC for our hex. Okay, so I want you guys to see these 3 for the, what is it, for our decoder. Okay, not be confused. This is for our decoder, this 4 is for our hex. Okay, now if we make as such, we know that this is equivalent to 4000. So our starting address is now 4000, and as said, 8K is equivalent to 1FFF. So it's 0000 till 1FFF, because if 000 till FFF times by 2, we know that it's gonna be 2. It will rise till 2000 lah. So 4000 plus with 1FFF will be 5FFFF, which will be resulting in 0000 till FFFF. Now the memory is located, the hex is announced, and the decoding table also we already get. So if 0 it's Y0, if 1 is Y1, if 2 it's Y2. Okay, so this is the table. We have done the table including the decoder. Now we need to draw. How do we need to draw? We need to add the 8-bit latch and also decoding circuit. So actually they need a decoder lah. Okay, this is the stuff that we need to do. So let me actually draw by hand to make sure you guys know what to do during the exam day, or during your, anyway that's gonna, you're gonna use this, maybe, God knows. AD0 till AD7, then we have ALE, then we have A8 till A15, then we have read and write. Okay, this is the block diagram. Now then we have D latch. Immediately do the D latch first. Okay, now we are gonna put AD into D. Okay, then as said ALE into enable. Then we're gonna put a outline here naming 8. Alright, and here a upline gonna go as such, and we're gonna write it here D0 till D7, because it's a data line. When it's going here, it's gonna be A0 till A7. Okay, so the line. Now this line is gonna merge here. Okay, we're gonna make it as 8 2. we know that it's gonna A8 till A15. Now when it's going out here, it's gonna be 16 and it's gonna be AO till A15. Okay, now the next part is you just write it as RD and WR, right? So which would make it easier a bit. Now A, B, C, this is 3 to 8 decoder. If you want to write full, it's good. If you don't want to write full, then welcome to my gang. Now we have G1, G2A bar, G2B bar. As said, this is plus 5V and these both are connected to the ground. Okay, now from here pull A, B, C, but refer to the table. A is A13, B is A14, C is A15. So you need to write here A13, A14 and A15. Okay, now the first thing that we're going to do is our 4K RAM 1. So if we write it here for K1 as RAM, so chip select. So this is our RAM 1. So Y0 is going to be here because it's going to select the chip 1. Okay, chip 1 because 4K RAM 1. Now as I said, RD for the output. So RD, okay, because it's showing a wire going on here, it can connect here magically. Now the output should connect to the output. Okay, so just stroke it as 8. This one just make it as such because this is output. Now here our address is going right. Pull the address, but notice here we are only going to use AO till A11. So make it as 12 line and name it as AO till A11 because there are 15 line going here. So we are just pulling 11 line. So we're going to do the same stuff. Okay, we're going to do the same stuff. Let's see if we can copy this. Oh, technically we can. Nice. But in the paper pen system you can't actually copy it, so beware of that. We're gonna connect it here. Nice, cool. So it's gonna be 4K 4K2 Y1. It's gonna be connecting here, and as said, you're gonna make it as such, and it's gonna be 12 line again. Here it's gonna be RD again, and you're gonna write A0 till A11. Now the last part, the 8K RAM. 8K RAM. We have the chip select 2, we have the output enable, we have the write, we have the AO till A18, A12 supposedly. Then we have the IO0 till IO7. Now for this box, we know that IO is our output, so IO need to be connected here too. So stroke 8, and our address line is going to be out too, because God knows we're going to connect USB or external memory, right? Now here, because of 13 lines, we're going to do 13 A0 till A12. This is going to be write and this is going to be read, because OE is read and WI is write. Now Y2 is be connected to CS. Okay, so this circuit is actually here. Okay, this is the correct, not correct, schematically more accurate or more nice to watch. Now the last question is a coding question. So for this code, what are they trying to ask us? Now if you see, they say that write an assembly program to store 05 to RAM area starting from 4000 till 4000. Don't know how we did it, but see here, they say that RAM 4000 till 4000. So technically we did it correctly, or else you should have seen the second question and then you should have made RAM address 4000. Okay, never mind. So origin, we start from 0000H, or if your program says that it's going to be 8000H, then start your origin with 8000H. Then load your H with 4000H. So what's going to do is, we know that it's BC, DE and HL. So 4000H is going to be 40 and 00 in the memory. So your HL going to be as 40 and 00. Okay, we're going to just see the pair. So load pair H with 400 means they're going to load as such. Now move A05. So we're going to move 05 into the accumulator. Now we're going to make a loop here. We're going to say that move MA. So we know that A is 05. Okay, A is 05. Now we say that move MA, meaning that our LXI saying that 4000 hex. It meaning that in a memory it's pointing for 000 hex. Okay, now the code is telling move A into M. Our M is showing 4000, and then okay, here load pair H means HL pair, and HL pair is also said as M. Okay, so move M means you move to the address that's in the M, right? Not to be confused. So we are making 05 into 4000, so 05. Okay, now increase L, meaning that this gonna be 1. Now jump not loop, meaning that is our L equivalent to 00? No. So jump not 0, it will loop back. So loop means move M 8. So now our M is showing 4001H, our new M. Then move A into M, so 05. Then it says increment L, so it's going to be 402. Is it 00? No. So loop back. Our new memory is going to say 4002. So move 5 into the new memory. Then make it 3. We will do as such until FF becomes, if you increment FF, it will become 4100. So our L has become 0. So it is 0 ready. Okay, the 0 flag is raised. So jump not 0, but 0 is actually 1. So it will become hull. So what is happening is our L was 00. So we're going to increase it till it becomes 4100 again, meaning that it's going to be 40 FF. Then it's going to turn here, it's going to off here. Why? Because the 0 flag is raised as 1. We mentioned that if 0 flag is 0, then loop. If 0 flag is 1, it will go to hull. The question said that 4000 till 40FF, 4000 till 40FF. So that is all. Thank you.